Hello everyone, this is Trisha Naik from third year electronics, and today I'm going to be designing an integrator using op-amp OP07 in LTSpice. So first let us see the calculations for the resistors and capacitors which we are going to use. So it is given that my FA and FB is 100 Hz. This is what I am considering. FA is 1 kilohertz and FB is 10 times FA, which is 10 kilohertz. I'm also assuming that my feedback capacitor is 0.01 microfarad. So the formula for FA is 1 upon 2 pi RFCF. So my FA can be replaced, can be inverted, and my RF comes out to be 1 upon 2 pi FA into CF. Therefore, the value of my RF, that is my feedback resistor, comes out to be 15.91 kilo ohm, and I've used the standard value of 16 kilo ohm. Similarly, my FB, the formula for FB is 1 upon 2 pi R1 CF. Therefore, my RF comes out to be 1 upon 2 pi FB CF. And if I put in the values, my RF is 1.5 kilo ohm. For my offset compensation or offset minimizing resistor, I take a parallel combination of R1 and RF, which comes out to be 1.37 kilo ohm, and I'm taking the standard value of 1.3 kilo ohm. So let us now make this circuit in LTSpice. I'm going to open a new schematic, go to components and type in OP07, and I'm going to place it here. Next, I'm going to place all the resistors required, one at the input, one for feedback, and one for compensation. Now for my capacitor, I'm going to place it in the feedback path. Now for my voltage sources, I'm going to type in volt. This one is for the input, and I need two more for the op-amp. Now for my grounds, this is for the inverting terminal, the non-inverting terminal, and the DC voltages. Now I'm going to join all these with a wire. I need to move my resistor. Yeah, now I need to join these with a wire. Similarly, the non-inverting terminal as well. For the feedback path, I'm taking out a wire first for V0, and now I'll make the feedback path as well. I'll join the capacitor and also the DC voltages. Also join them to ground. Now I need to label my V in and V out. So I'm labeling this as V in and placing it here. Similarly, right click, label net, and I'm labeling this as V out and placing it here. Now for the VCC and VEE, I am taking out two wires at these 2 points. I can right click here, go to label net, and I'm naming this as VCC, connecting it here as well as here. Similarly, at this point, label net, and I'm naming this as VEE here as well as here. Now I'll give this a value of 15 volt DC. So you just need to right click and the DC box will appear. You need to give 15 volt. Now for the value of the resistors in the capacitor, my Rn or R1 had come out to be 1.5 kilo ohm. So I'm going to give it as 1K. My RF or R2 had come out to be 16 kilo ohm. And my capacitor was 0.01 microfarad. And my R compensation was 1.3 kilo ohm. So let us first check. Let's go to advanced and click on sine. We'll first check what output we get for an input, for a sine input. So here I'm going to give 0. I'm given an amplitude of 1, which is 2 volt peak to peak, and a frequency of 1 kilo. I'm clicking on OK and I'm running this. This will give me a pop-up for a stop time. I'm going to put this as 10 millisecond for now. We can always change it later. Now I'm going to place this on V in and V out. So we can see here that for a sine input, we get a cosine wave at the output terminal. Now let us change this and give a square wave for an input. So for a square wave, you need to click on pulse and change these options. Give this as -1, the second one as 1, and keep these 3 as 0. Let us give T on as 10, 100, and your T period should be twice of T on, so that is 200. And click on OK. I'll use this option to drag this here so it is a bit more visible. Now let us run this. Check the input as well as output. Yeah, so we can see here. Let us reduce this a little bit so the waves are a bit more wide and visible. Yeah, so here we can see that for a square input we get a triangular waveform at the output for an integrator. Now let us give an input of a triangular wave. So similarly you need to check pulse again. These values will change. So I need to give a value for T rise and T fall. So I'm going to give 1M and 1M. Let this be 0 since we don't want a T on period because we need to create a triangular wave, and this will again be double, so 2M. And let's click on OK and try and run this now. This should give me a triangular wave like here, and this is my output. So now I need to increase this again for the triangular wave so it is a bit more visible. Yeah, so as I can see, for a triangular input I get a sine wave for the output. So now these were the output waveforms. Now let us check the frequency response. So for the frequency response we need to again right click over here and go to none for this and put an amplitude of 1, which is 2 volt peak to peak in my case. And let us remove this because this is not required. And now let us simulate. Now this is default, it will be on transient. We need to take it to AC analysis. I'm going to do an octave sweep. My start frequency I'll put it as 1 Hertz, and the stop frequency as 100 kilohertz. And let's say I want 100 points per decade. And when I click on output, this is my frequency response as well as phase response for an integrator, since you've designed a practical integrator. Now this gives me a frequency and phase response in one window itself. So if I want to see only one of them, suppose I want to see only the magnitude part of it, I can click on the phase part and click on don't plot phase. This will give me only the magnitude. Similarly, we can also check only the phase plot. Now for the readings, as I've taken in my case, my FA is 1 kilo and my FB is 10 kilo. So these are the frequencies for which I have taken my readings. I've taken V out, gain and gain in decibel. So first for V out, let us right click here and go to linear and click on OK. So this is my V out, that is volt from peak to peak. Now wherever I keep my cursor, I will see that the value at that point on the curve at the bottom left side. So I can suppose I keep my pointer at 100 Hertz on my wave. I can see that my value is 10.60, which is the value I have put over here, a similar value. So now if I want to find the gain, I need to add a trace. So I go to plot settings and go to add trace. Now gain is always V out by V in. So I first click on V out and divide it by the input. And I click on OK. This adds another trace. So as I can see, my waveform for the V out and the gain is similar. So here again I can place the cursor wherever I want to and get the readings. Now for gain in decibel, I have to right click here and go to decibel and click on OK. Now this is my gain in decibel. Again similarly I can place my cursor or pointer here and get my gain. This is the design for a practical integrator, and in this video we have seen the frequency response, phase response, as well as output waveforms for a sine, a square as well as a triangular input. Thank you.